Let's see a real-world application of k-mean algorithm. And I'm going to use an example of image compression to introduce the application of k-means as well as clustering algorithm method in machine learning. So this is a very beautiful picture. It's a tower. And now I'm trying to, it's very common questions in our real world life, how to compress a picture. So this picture is very nice, and it's very colorful. And It ha in this picture it has all of the picture made of consists of pixels. Each pixel is consist of three value. Three value are RGB value. R means red, G means green, B means blue. So uh, RGB each of them represent a number. So three different number combined together can make a new color. So in this picture, it has many pixels, many pixels each row and each column, and many pixels, and each pixel represent a color. So can we use algorithm k-mean algorithm to cluster this picture into different clusters, split picture into different clusters. Like you see, in this part, it seems that the color are close to each other. It's all light blue. Here is little white. Here is dark green, and it is yellow, red, yellow. So can we split into different clusters, and each cluster the color is similar, and we can use one color to represent all of the color, all of the color in that cluster. So we use one number to represent all of the numbers in that cluster. So this is what we want to figure out by k-means algorithm. It's very helpful for us to compress the picture for easy store. So let's go ahead and see it. So in here, I just write down the k-mean algorithms. K-mean algorithm. This algorithm I just input from library, and I applied k-mean algorithm in this picture. And I in this is the original picture. Original picture, it has it consists of more than 96,000 colors in this picture. But in here, I only use 64 colors to represent the whole picture. So it means I split the picture into 64 clusters. And you can see here, this part belong to a cluster, and this is another cluster. This is another cluster, and this part. You see, so I split I use one color to represent all of the colors in this cluster. In the beginning, in the first step, I split the picture into different clusters. And I use the one color in that cluster to represent all of the colors in that cluster. Now, you may ask, how did we do that? The formula is, so each pixel consists of a RGB number. RGB is three number. We can put that three number in a three-dimensional coordinates, and it's just the data points in the three-dimensional coordinates. And if the color are close to each other, are similar. If the color are similar, it means in that three-dimensional coordinator, the data points are also close to each other. So in that case, we can convert our color question to distance question. If the two data points, their distance is very short, it means they are close to each other, then we can think they belong to the same cluster. It also means their color is similar. And we put them in the same cluster. So yeah, in that case, we can put all of the pixels, the values of the pixels into three-dimensional coordinates, and then we get a new data set. That is the data set that we have, and we apply k-mean algorithm on that. We split the data that data set into k amount of clusters. We set up k by ourselves. In that we split that data set into k amount of clusters, and that data set can have many clusters, and in each clusters we use its centroid color to represent all of the color in that cluster. So this is the formula for the k-mean algorithm on image compression. It's very useful and powerful. In here, we also can choose different k value. We can choose k equal to 4 or 100. I can make a demo in here. Now in here, I choose k equal to 64. If I choose to 2, it means we split the data, we cluster in the data, the picture, the data set into 2 clusters. Let's see what will happen. So now it's belong to 2 colors, only white and black. If I increase it, if I choose 4 clusters, yeah, it's a little better. It's better. It's more colorful. If I choose 10, let's see what happens. Now more colorful. 4 cluster splits the data set, the picture into 4 different parts, 4 different clusters, 10 different clusters in here. And I choose 20. What will happen? See? 20. It's more close to it. 40. More colorful. It's very close to the original picture. So with k-mean algorithm, when we apply it on image compression, we can just use very less data to store the picture, store the image, and reduce our storage. So in here, now we only use we use 40 colors and store this picture instead of 96,000 colors in the original picture. So this is one real-world application of k-mean. I hope it is helpful, and I hope you can understand it and use it in the future.